final answers to your warm-up are up on the smartboard for you. So walk around looks pretty decent. What I like about this warm-up is that it is like a nice representation of really everything we've done so far in the chapter. You had to examine multiplying radicals, combining like radicals with addition and subtraction. Simplifying radicals is something you had to take care of. So this is really a really nice warm-up because it's a nice summary of what we've done so far in the chapter, much like that assignment you just handed in. But for number 1, your answer there is -4. Do you need a copy? There's extra copies in the back. Help yourself. You could just rip out the page you need. So yeah, number 1's -4. We'll talk a lot more about that type of problem tomorrow. The relationship between the square root of 5 minus 3 and the square root of 5 plus 3 is actually an important one. Number 2, I again use the distributive property in conjunction with our product property. For instance, the square root of 6 times the square root of 3 is the square root of 18. And then that did break down to 9 and 2. So the square root of 18 simplifies to be 3 root 2. And then when you take 3 times the square root of 6, you can't combine those because they're not both under the radical. So what you get is 3 root 2 plus 3 root 6. I have a question about number 2, y'all. Number 2. Could I have combined those? I have 3 root 2 and 3 root 6. Why not, John? Do you know? Yeah, very good. We have root 2 and root 6. They're not like radical parts, so we cannot combine them. Number 3, I use my properties of exponents first. We are going to review those very soon, actually. So you have like x to the first over x to the fourth. Remember, they do battle with each other. Like x to the first is on top, and then you have 4 x's on the bottom, and the one on the top takes the one on the bottom. So you see how it's like 1 over 8x cubed there? And then I cube rooted the top and cube rooted the bottom with my quotient property for radicals. Simplifies to be 1 over 2x. And then number 4, I was allowed to multiply those two things together. 20 times 5 is 100. X times x to the third is x to the fourth. And then I use my product property to simplify, so you get 10x squared. Does anybody have any questions on those 4? What's up, Darius? Is this the 2 you're mentioning? Yeah. So I didn't show it, but I did use the product property on the bottom there. Like I had to take the cube root of 8 times the cube root of x to the third. So the cube root of x to the third is where I got the x from. What number can I raise to the third power to get 8? That number is the 2. There were 5 numbers we had to remember that were perfect cubes. So it goes like 1, 8, 27, 64, 125. Those are those numbers. What's up, Alexis? So do you see how it was x to the first on the top and x to the fourth on the bottom? Yeah. So to do a little more scratch work for that, it's like we have x to the first over x times x times x times x. Those reduce out. So you have x to the third left over on the bottom. We actually defined that in saying, you know, we could actually subtract the exponent. You do 1 minus 4, it's -3. So x to the third had to go on the bottom there. Well, to be honest, I was seeking out perfect cubes. And I knew that if I reduced x and x to the fourth, I would get a perfect cube out of that, which is nice because I had to take a cube root. No.
I understand like why you would
I don't see squaring. Well, What would you cube?
I'm just talking
I-
about
I understand that, but I'm just saying, how would you apply them? Like you were going to, I'm trying to see what you're seeing, John. I don't know how you would actually do that. Do you mean cube root? Because you're saying cubing. Okay. I was like, where is he saying cube? Okay. You could, to be honest, out of all honesty, you could cube root the top and cube root the bottom. But remember, we look for the easiest way to do the problem. So if you want to cube root x, here, I think this is the way you were going to approach the problem. You could correct me if I'm wrong. But this was the cube root of x over 8x to the fourth. And I think what you were thinking, which is fine, you were going to take the cube root of x first. Okay. So, yeah. And then you had the cube root of maybe 8, and then the cube root of x to the fourth. So we're then stuck with this simplifying business that we did last week. The cube root of x doesn't simplify. 3 doesn't go into 1. That's done. Cube root of 8 is 2. And then if we ask ourselves, well, hey, how many times does 3 go into 4? That's 1 time. And then there's 1 left on the bottom. So in all honesty, you could have done the problem in the same way, but that's longer, I think. So I look for the path of least resistance. I would try to just simplify first. Makes the problem faster. So you could have done it both ways. Any other questions about that warm-up? Good job, guys. Well done. All right. I like the questions that I was getting on that third one. That's good. I like those. Today, what we're taking care of is, like I said, we're starting to divide radical expressions. And the problem that we're going to run into is sometimes we're left with a radical on the bottom of a fraction. From this point forward, we're not allowed to leave that radical down there. So when you go through your homework tonight, did you look at the whole paper? There's square roots all along the bottom of all of the fractions. And your mission is to get rid of those square root symbols that appear on the bottom of a fraction. When we do this, this is a process called rationalizing the denominator. When square roots are in the denominator, which is the bottom, it is customary to do this thing called rationalizing the denominator. Do you see how it uses the word customary? So funny. It doesn't say it is wrong to leave a radical in the bottom of a fraction. It says customary. You know, just like it's customary to not leave an answer like 2/4 on a test, right? 2/4, you would write that as 1/2. You wouldn't leave me an answer of 2/4. We're in the habit of observing the custom of leaving our answers in lowest terms. Very similar idea. It's just customary to write our answers in this way. We don't ever leave radicals in the bottom of a fraction. It's just really poor notation. We should, from here on out, never leave a radical in the denominator. So that needs to start catching your eye. Square root on the bottom. Uh-oh, got to get rid of it. That's kind of the big idea for today. Over the course of this week, we're going to show you how to get rid of the radical in the bottom of the fraction. We're only going to take care of this first case today. You know, and if you look at your worksheet tonight, you'll see that this is the case that's being assessed today. We see that what if there's just the square root of 3 or the square root of 7 or the square root of 14 on the bottom of your fraction? And quite frankly, you would just multiply the top and bottom of that fraction by the square root of 3. So here's what happens. Check it out. If the square root of 3 is on the bottom of your fraction, and you multiply that by the square root of 3, essentially what we're doing is the square root of 3 times the square root of 3. Using our product property from last week, we've come to understand that that is the same as the square root of 3 times 3, or the square root of 9, which is 3. Look at that. No radical. Poof, gone. So nice. Another way of looking at the square root of 3 times the square root of 3, because it's the square root of 3 times itself, we could say that's the square root of 3 squared. Well, the square and the square root are inverses of each other. They undo each other, so you get 3. That's another way of looking at it. What we're going to do is use this radical to help us get rid of the radical in the denominator, essentially rationalize some of our denominators. We'll come back to the idea of a conjugate pairs tomorrow. But for right now, your homework looks a lot like example 1. And that's what we're going to practice with today. We have to practice getting rid of radicals in the bottom of the fraction. Just when there's one hanging out down there. So if you take a look at part A, it says 5 divided by the square root of 2. The square root of 2, that square root symbol is not allowed to be down there. So what we have to go ahead and do is multiply the top and bottom by the square root of 2. Now why I have to do it to the top and bottom is because the square root of 2 over the square root of 2 has a value. The square root of 2 over the square root of 2, that's just 1. So I'm just multiplying my fraction by 1. And in doing so, I'm not actually changing the numeric value of the problem. I'm just changing the form that it comes in. It's really similar to when you reduce 2/4, like I said earlier, to 1/2. They're the same number, you're just reducing out that common factor of 2. So here, I'm going to multiply the top and bottom by root 2. When we multiply fractions, we just multiply straight across. So I'm going to take 5 times the square root of 2, that's just 5 root 2. And then I have to multiply the square root of 2 times the square root of 2. Square root of 2 times the square root of 2, that's the square root of 2 times 2, or the square root of 4, which is, ta-da, 2. So the radical went away. We have 5 root 2 over 2. Now, just to show you I'm not full of baloney, here's how you're going to check your homework tonight. What we went ahead and did throughout the course of my college algebra lessons today is I showed them that you could put the original problem into your calculator and your worked out equivalent, you should get the same decimal back out. So what I'm having you do today is, for instance, we could enter into our calculator, the original problem was 5 divided by the square root of 2. Get this decimal. It's an irrational number. Do you see that non-terminating, non-repeating decimal? Goes on and on and on. That's what 5 divided by the square root of 2 is. It's a little bigger than 3.5. What I'm having you postulate right now is the fact that this is actually equal to what we just worked out on our paper. In other words, I'm asking you to check that 5 divided by the square root of 2 is actually the same as 5 root 2 divided by 2. And it is. Do you see I got the same number both times? You should be able to do that with your assignment tonight. You enter the original problem into your calculator real quick, and then you enter your rationalized version into your calculator. You should get the same number back out. Okay, let's try it a couple more times so you get the feel for it. A little reinforcement. So for instance, in part B, the offender in this case is the square root of 7 that's on the bottom of the fraction. You're not allowed to have radicals down there. So you would just multiply the top and bottom of this fraction by the square root of 7. And then when we multiply fractions, you just multiply straight across. So we're going to take the square root of 10 times the square root of 7. That's the same as the square root of 10 times 7, or the square root of 70. Excuse me. Thank you. And then we have the square root of 7 times the square root of 7 along the bottom. The square root of 7 times the square root of 7 is the square root of 49, which is 7. So poof, 7's on the bottom, the radical went away. This is indeed the same as my original problem. I'll show it to you on my calculator again. So I took the square root of 10 and divided it by the square root of 7. Whoa, not that, square root 7. Hit enter. And what we're trying to figure out is that the same right now as the square root of 70 divided by, we got 7 on the bottom there. And look, it is. See how we get the exact same number back out? So that's kind of how you're going to check tonight. You don't have a back of the book. You don't have an answer key. You're going to look at your calculator to kind of check your work a little bit. All right, let's do it again. Part C. We have 14 divided by square root of 7. What we're going to go ahead and do is multiply the top and bottom of that fraction by the square root of 7. 14 times the square root of 7, that's just 14 root 7. Square root of 7 times the square root of 7 is the square root of 49, which is 7. But this isn't done. I see is 14 over 7 is part of my answer. Well, you can reduce that. 7 and 14 have common factors of 7. 7 goes into 7 one time. 7 goes into 14 twice. So the best answer for this problem is actually 2 root 7. You could check it on your calculator. So I have 14 divided by the square root of 7. And right now we're trying to figure out if that is the same as 2 root 7. And it is. What's up? I think you're confusing the rules for addition and subtraction with multiplication and division, yeah. The phrase we use when we add or subtract is combine like radicals. But for multiplication and division, we have our product and quotient properties, so it's a little different. One last one. We have 5 divided by 4 root 2. There's a long way you could do this problem and a short way you could do this problem. As I was saying earlier, value the path of sort of least resistance. I'll take the easy way out. You could multiply the top and bottom by the entire denominator in this case. But I'm going to go ahead and just multiply by the root that I see. So I'm going to multiply the top and bottom of this guy by the square root of 2. And then when I multiply fractions, I multiply straight across. So I have 5 times the square root of 2. That's 5 root 2. And then I have on the bottom 4 times the square root of 2 times the square root of 2 there. Do you see how multiply straight across, you're taking this times this? When I multiply those things together, I have 4 times the square root of 2 times 2, which is actually the square root of 4. And that simplifies to be 4 times 2, which is 8. So the 8 is my new radical-free denominator. So 5 root 2 over 8 is your answer there. And you can check this in your calculator. It is actually logically equivalent to the original problem. You're going to try one. I see some of you quickly turning to your worksheet for tonight. I really like that you want to just kind of get started on that. You know, you're feeling good about it and you want to move on to the next thing. I want you to try one more problem on your own for just a second before you go ahead and cut yourself loose on the worksheet. The problem I want you to go ahead and try real quick for me is just number 1 on your conclusion set. 1 divided by the square root of 5. I want you to take care of that one for me real quick. And then if you get that one right, then you can go ahead and look at your homework for the next round. You guys did a really nice job with this. Gets a little tougher tomorrow, but your first day of it's going pretty well so far. As I walk around, people were multiplying the top and bottom by the square root of 5. So we get for our final answer square root of 5 over 5. Some of you are leaving the 1 there. That's not incorrect. It's just we don't normally leave that there, but it's not incorrect. Okay, questions about our lesson for today? Because now you get to practice a little bit of your homework. You're good? All right.